So thank you for the invitation. I'm delighted to be here. I come all the way from Florida. Yes, we do have winter in Orlando. It's usually the 26th and 27th of January, just in case any of you wondered that. So before we get started, I have just a couple of questions to ask. First of all, are there any folks in the audience who actually know what amateur radio is, have personal experience with knowing what it is? Okay, maybe half a dozen of you. Is there anybody here who's actually a licensed amateur radio operator? 1, 2, 3, 4. Which is really quite amazing. I gave a similar presentation at an IEEE sponsored conference in Naples, Florida earlier this year, and I would say there were 100 people in the audience and not a single one of them was a licensed amateur radio operator, which was a little bit frightening because it was full of, and I say this respectfully, techno geeks. There were people who were electrical engineers and communications and physics and things like that, and which is my background as well, but I was relatively surprised at that. So as we're ready to get going here, I do have a comment about laws. We talked about some of the laws that the FCC is working on. Shall I do something here? Let's see, unknown device detected. We'll just do this. Can't ignore it. Close it.
This is what we do with security.
This is good. I'll close it again. I'll close it again. Okay.
Maybe you just go down to your PowerPoint on the bottom.
Yeah, it wouldn't let me do that. Let's try it again. All right. Okay. So about laws. So most of you know what Ohm's law is. Show of hands, Ohm's law. Okay, that's good. Murphy's law? Murphy's law? What about Cole's law? Thinly sliced cabbage. Okay, all right. Moving on. So let me talk a little bit about why the next 19 minutes or whatever my half hour turns out to be. Okay, I'll try not, because I am the one standing between the rest of you and cocktails, and I understand that. But let me talk to you about why this is going to be different. So I'm a technologist. I'm an obsessive technologist. I'm curious about everything technology related. I wanted to be an air pollution scientist when I was a kid. I ended up studying electrical engineering, then civil engineering, then chemical engineering. So I'm a techno geek of my own. But this presentation is really not technical. So I want you to take this in the context of pretty much everything else you've seen today is rooted in technology and how important technology is to solving problems. This actually takes a little bit of a different track. It talks about things that are non-technology related and how those things may be just as important in solving a problem as those technology issues. So a little bit about myself. I became a shortwave listener, if anybody knows what that is, listening to Radio Moscow, the Voice of America, Radio Prague, Radio Australia, and so on. When I was 12 years old. I got my first ham radio license when I was 14 years old. I do have an electrical engineering degree, which is why I suppose that validates the fact that I was invited to the conference here, because I've got to have those EE letters in my credentials. Yes, I've lived in upstate New York before. Schenectady, New York. I was actually born in Schenectady, the city with the zip code 12345. In case that turns up on a trivia test, Schenectady has the zip code 12345. Although I was born before zip codes, so I was not born in that zip code. And I'm kind of and I don't mean this in a boasting manner, but it's a factual thing. I've started a few companies in the field of wireless communications. I started a company in 1992 that was the first company to actually take distributed processing and apply it to mobile data for police. Motorola, somebody, you've heard of Motorola before? It's a small company headquartered maybe here in Chicago, Schaumburg. Motorola had done something called mobile data terminals, and we took it to the next level by applying distributed processing, putting laptops in police cars, and we went from 3 guys in 3 garages to $150 million exit in 1999. So I know a little bit about technology and how to apply it, but again, forget all that because this isn't going to talk about technology. This is going to talk about my personal perspective and what amateur radio has done to my brain with regard to solving some of these real-life problems. So just a couple of really strange things. If you thought I was weird to start with, this is going to confirm it for you. So in 1979, I did something really strange. A little bit of background. Ham radio operators are very competitive. There are contests throughout the year, there are all kinds of things, and you need to win them. And winning them means that you get $1 million, no, you don't get anything. You get a certificate to hang on your wall, and you get bragging rights. However, there are people who collect countries. If you talk to a specific country, you get to check it off on your list. And he who has more countries has got better bragging rights. Well, there's this little place in the South China Sea called the Spratly Islands. It's been in the news a lot in the last decade or so because the Chinese are adding sand to it to make it bigger and claiming oil rights and things like that. But in 1979, it was a hotly contested area. China was at war with Vietnam at the time. It was after the US had left the Vietnam War. And it was a pretty hostile area. Although our contacts at an agency, sometimes called the Department of Agriculture in Virginia, although many of us know that it's not really dealing with agriculture, told us it was safe. No problem going there. Well, we found Vietnamese troops when we were there, and they shot at us. They didn't kill us, but they did kill 3 Germans the next year who tried to go back there and do the same thing. And we went for the sole purpose of bringing radios and bringing towers and bringing generators and setting up an ad hoc operation so we could give out Spratly Island to all of those deserving ham radio operators around the world. In 72 hours, we made 13,000 radio contacts with people around the world. Kind of interesting. Another weird thing that I did is I had occasion for work to go to China on a regular basis. And I started doing it in the late 1970s, early 1980s. And there had been a dearth of amateur radio activity in China since the Cultural Revolution had taken place in the mid to late 1940s. There had been no amateur radio operation at all until, mysteriously in 1982, BY1PK, BY is the prefix for China, 1 is the prefix for Beijing, and PK stood for Peking University. So the university club station started making contacts. Well, it was interesting. They'd get on the air and they'd say, hello, this is BY1PK in China. And of course, everybody needed China to check it off on their list. And there would be this massive, what we call a pileup. And they'd make 1 or 2 contacts, and then they couldn't hear anybody because it was just cacophonous, and they'd go away. And this was very frustrating. So I offered to train them on how to handle these kind of pileup situations. And I heard nothing for months. And then all of a sudden, out of the clear blue sky, I received a telex. Anybody know what a telex is? Okay. From the China Radio Sport Association saying, come on, why don't you come and help us train the operators? So I became the first non-Chinese to operate amateur radio since the 1940s when I did it in 1983. Kind of strange. And then here's one little thing that's more relevant to the topic today. So in 1972, there was a major flood in, I'll call it south central New York, eastern Pennsylvania. Some of you may have actually lived in that area and know all about this. The Chemung River overflowed, flooded nearly the entire city of Elmira, New York, and also went down into the cities of eastern Pennsylvania as well. The worst flood in New York since the 1940s. Tens of thousands of people were evacuated from their homes. And I was in Buffalo, on my way back from Buffalo, driving my 1972 Chevrolet Vega with my HF radio installed under the dashboard, and they put out an emergency call for amateur radio operators to help with relief efforts. And I said, gee, I wonder what that's all about. So I drove to I drove to Chemung County, to Elmira, and I became part of the disaster relief team. And we actually were the only people who were coordinating delivery, arrival, delivery, distribution of sleeping materials, food, medicine, blankets, and so on that were arriving at a nearby airport, courtesy of the government in their C-130s. It was really eye-opening. I was there for 5 days, and I learned all about what disaster relief is and should be. It's fascinating, absolutely fascinating. I don't think it would be the same today. Number one, I'm not as impressionable as I was when I was 17 years old, but also technology has moved on a little bit, and let me talk about that just a bit. So one of the laws we need to pass, by the way, if the gentleman from the FCC is here, you might want to take this under consideration. We need to stop disasters. Okay, so we can put that in the law, and if it takes as long as most laws to do, then sometime between now and 2030, there'll be no more disasters. But there are all kinds of things that we don't anticipate that plague us on a regular basis. When I say don't anticipate, yeah, we can forecast hurricanes like we forecast Hurricane Dorian. And I know you folks don't live in Florida, maybe one or two of you do, but I do. They forecast Hurricane Dorian to make a mainland hit right between Miami and Daytona Beach. And instead of doing that, it decided to park itself over the northwestern Bahamas for 3 days and not move. And we actually never saw any effect of a hurricane whatsoever. So you can have the downside of it and you can have the upside of it. So a hurricane can come without warning. It can change wherever it wants to go. There are floods, tornadoes, other kinds of emergencies that are not weather related. We talked a little bit about forest fires earlier and what they're doing in California, volcanic eruptions, and there are probably all kinds of disasters that I haven't even considered here. But I'm going to talk a little bit about hurricanes. Hurricanes are very highly visible. They're very publicly aware. They're covered on the news. Everybody knows what they're all about. So in order to feed my presentation here, I relied on some information from a very good friend of mine that I've known since he and I were both in high school. He was in high school in Indiana, and I was in high school in Massachusetts. He's now the emergency coordinator for the Virgin Islands. He's an amateur radio operator, as I am, and his job has to do with two-way communications. He works for a tower company, but his side job, when he's not doing that, is being the emergency coordinator, in particular for St. Croix. And he works with emergency coordinators from others in the Virgin Islands as well. So he knows all about what's going on, and he is part of the people I'm going to talk about in this presentation. So Hurricane Irma, 2017. Unfortunately, the Virgin Islands got whacked twice within rapid succession. Devastated Barbuda, St. Thomas, and St. John. Barometric pressure was 914 millibars, which compared to Dorian was actually not so bad. But 160 mile an hour sustained winds, 200 mile an hour surface gusts. I mean, this is pretty much devastating to anything in its path. Fifth costliest in history. So that's what it kind of looked like. And these are pictures that were supplied to me by my friend K9VV in the Virgin Islands. Well, guess what? A few days later, Hurricane Maria. Even a lower pressure, 908 millibars. 165 mile an hour sustained winds, maximum surface gusts above 200 miles an hour. And again, this was about the same range as Dorian, which had gusts of about 210 or 215 miles per hour, if you believe what the reports say. This was the 10th strongest Atlantic hurricane ever. Devastated St. Croix, 95% of utility poles were destroyed. Keep that in mind for just a second as we go through the presentation here. And this received the most media attention of almost any hurricane actually, any hurricane in the Caribbean, not more than Katrina, but any hurricane that affected the Caribbean. And here are some pictures of what Maria did. They kind of look like the same pictures. I didn't use the same pictures. These, in fact, are traceable back to Maria. So let me talk a little bit about communications. So when one thinks natural disaster, one thinks of all the things we've been talking about during the day today, and we'll be talking about a little bit tomorrow, which are these communications infrastructures that are designed to be infallible, maybe, at least resilient, flexible, usable, and able to provide the service that they were intended to deliver during the time of a natural disaster. And this is an eye chart, kind of. It's got all these things. If I had a laser pointer, I'd point at all the little linkages and things here. It's pretty complicated. This is a very, very basic cellular system. I say fixed wireless. It could be mobile wireless as well, but it's cellular. Very, very simple, right? No, not really. So there are a lot of things that depend on commercial infrastructure. There's backhaul, there's power. You need to have poles if you're going to have cellular antennas, or you need to have towers. And if 95% of the towers and poles get knocked down, guess what? You don't have them anymore. So just a little bit of fragility. This is maybe not a typical tower, but I mean, I've seen lots of towers like this in my career in the wireless industry. The benefits of 4G and 5G wireless, of course, is that they're already in place. Somebody else maintains them. It's the telecom providers that maintain them. That's great. We as citizens don't have to do anything. But some of the weaknesses, the complex infrastructure is vulnerable. And the more complex it is, the more components are involved, the more vulnerable it becomes. It relies on things like towers and backhaul. And if they go away, the service goes away completely. And it's capacity limited, in particular at the time when it's needed, when there is an emergency. Now, with respect to the particular provider that was indicted by this headline, I eliminated the word Verizon. I eliminated the provider. It said Verizon Fiber suffered unprecedented damage from Hurricane Michael. This had happened after those hurricanes, but before I made this presentation. And one of the gentlemen who presented earlier today talked about the fact that one of the issues with providing service after a disaster and restoring power and restoring cellular service was the backhaul itself. And this is an example where in Florida in particular, the backhaul just never came back. So if you don't have backhaul, you don't have a service. Now, this is the amateur radio network. This is HF radio. Does this look a little simpler than the diagram that I had up there before? It's got two things that we provide. It's got a transmitter and it's got a receiver. And it's got this thing called the ionosphere. The ionosphere, for those of you who haven't studied physics, the ionosphere is just an ionized layer. It's an ionized arc. It's just like a mirror. You send a radio wave up to it. It's a little more complicated, but in a simple form, you send a radio wave up to it at a certain time of day at a certain frequency, and the radio wave bounces off and comes back to Earth. And that allows us to communicate way beyond the curvature of the Earth. In fact, people ask me often, how far have you talked by amateur radio? And I say, well, I've talked to somebody in California the long way, over Europe. So you can do that. And actually, you can bounce signals off the moon, and that's even longer. But with regard to this model of using the ionosphere as a reflective mirror, it's pretty simple. So what makes it even simpler is I can go get a transmitter out of the trunk of my car, and I can go plug it in, or I can go get a Honda generator, and I can put a little bit of fuel into it. I can start up the generator, plug my transmitter in, throw a wire over a nearby tree, and I could talk to somebody in Europe 15 minutes from now. Pretty impressive, pretty impressive. I don't rely on infrastructure. I don't rely on backhaul. I don't rely on towers. I don't rely on anything that the commercial infrastructure has to provide me. Now, this is the VHF UHF network, which is a repeater. And many of you may have heard that context before. This is the complete repeater topology for the Virgin Islands. And you can see we've got St. Thomas, St. John, and St. Croix, STT, STJ, and STX. But repeaters are pretty simple as well. I had a repeater at my house when I lived in Massachusetts. I just put an antenna 50 or 60 feet up my tower. I bought a little piece of thing and I piped it all together and I turned it on. And anybody who wanted to could actually talk. As long as they had range of my little 50-foot tower, they could talk to each other. Again, I could make it go on emergency power. Nobody needed to have any infrastructure, no commercial backhaul necessary, nothing required from the outside world. So again, self-contained and manageable is a key. So the thing about disaster response, again, we talked about technology. Technology is important, but when technology fails, what do you do? If technology isn't available, what do you do? Well, you've got to have training. So even the best alternative infrastructure, like the one I talked about, isn't going to be very helpful if you don't have people who are trained to be able to operate it and have it perform the function that it's intended. So amateur radio operators can participate in one of a number of different organizations, and I'll fast forward through this a little bit in the interest of time. But there are multiple functions that are provided. There's a little bit of project management, there's a little bit of frontline communications. They actually design, build, implement, maintain emergency operation centers in every state and every territory of the United States. They program radios, they understand where interoperability is important, they know where the weather channels are so they can listen to the weather channel if it happens to be on the air. They coordinate with and in some cases are embedded in the emergency forces of people like TSA or police or fire or other emergency responders. In fact, in the case of Hurricane Irma, HAMS assisted with air traffic control because the entire air traffic control system was down. So how did planes land? The amateur radio operators coordinated it for them. So these are two options. Those of you who are licensed radio operators might know about RACES, which is coordinated by the federal government, and another one called ARES, which is Amateur Radio Emergency Service. Both of them are staffed with volunteers. These folks are not just plain old volunteers like, hey, I think I got some time on Saturday to help out. They're actually trained. They actually go through certification in disaster relief and disaster relief communications. So again, their primary purpose is not to be the primary communicators, but it's to be the backup communicators when that primary system fails or becomes infallible. So pre-disaster checklist. Has anybody here been through a disaster where you've lost power, you've been flooded or something like that? You know, I have. Few? Okay. So you know, it's really easy to come up with this list afterwards. It's kind of hard to come up with this list beforehand because you got lots of other things on your mind, but it's worth taking away. You can download these slides from the website if you want to do this. Who's evacuating, who's staying, who is available as a resource, what other agencies can be called upon for certain specialized services or functions, what is the operating schedule for people, who's going to be available on this shift, and then who's going to take over in that shift. And then, of course, it's a bit trite, but expect the unexpected, because the unexpected always happens. Murphy's Law again. So you need to have contingency plans to put into place when those deviations occur. So just a little bit about, I did some pros and cons about the fixed wireless or the cellular paradigm that we talked about, which is the one that we all rely on for communications during a disaster. Let's look at amateur radio. Key benefits: can be deployed virtually anywhere. And as I said, I can deploy this in my backyard. And I'll show you a slide. In fact, there are some slides of some folks putting up towers right here. Very simple to operationalize. It doesn't require anything more than somebody who has a license and somebody knows how to plug in a piece of coax into the back of a radio panel and turn the on switch. It's not dependent on any existing infrastructure at all. You might say it's dependent upon power, availability of power, but as I said, I can go down to Home Depot and I can purchase myself my own little portable power pack, and off I'm running. You can do batteries, you can do generators, and they last quite a long time because, again, it's a very simple model, so we don't have lots and lots and lots of things to light up. It's a relatively simple model. And there are a large number of trained volunteers, so there are people who can step in and actually make this all work. Potential weaknesses: it's not accessible to the general public.
Why do you say that?
General public can't get involved in the communications themselves. So if you're on a cellular system, you're the general public. You can take your cell phone and you can make a call. You can make a 911 call, or you can coordinate with somebody. But you can't do that unless you have a license. Right.
But anybody can get that.
Which is great, straight man, because that's coming up in 2 slides. So that's good.
This is called getting involved.
That's right, exactly. Another potential weakness is it can be affected by ionospheric disturbances. So there are things that happen to the ionosphere that are related to the sunspots and solar flares, and it's all astrophysics. And I understand it pretty well, but it's really complicated. I understand it to the point to know that I really can't explain it in the time frame I've got here. But suffice to say that ionospheric disturbances can kill everything. Like all of a sudden, boom, done. You're talking to somebody, and then all of a sudden, 15 minutes later, there is absolutely no propagation to that part of the world anymore. And this applies only to those communications that are not line of sight. If it's line of sight communications, that's a different story, talking about bouncing things off the ionosphere. So lessons learned, okay. I've been involved in disaster relief off and on my whole life, and I could tell you that you need to confirm something that doesn't make sense. Now, that's kind of a good life lesson too, isn't it? Somebody tells you something, you say, you know, I'm not sure that really makes sense. Be curious. Dig into it. For example, a real experience that was related to me by my friend in the Virgin Islands, somebody was talking about Delta Kilo Alpha. And they actually didn't say Delta. They say, oh, it's got DKA. And they heard EKA. And they said, what's EKA? And they said, oh, I don't know what EKA. That person's got EKA. And they relayed this to the first responders. Delta Kilo Alpha would have clarified that. It's DKA, which is diabetic ketoacidosis, which is a life-threatening condition for somebody who is afflicted with it. So that had to be confirmed 3 times before it was done. So again, lessons learned. If you don't understand something, clarify it. Pay special attention to detail, maintain vigilance, and so on and so on and so on and so on. And by the way, the last point on here is pretty important. The FCC recognizes the public service value of amateur radio through the free license grants that we enjoy. I don't pay for a license anymore. I last paid for a license probably in 1985. And the FCC decided it's not worth putting people through this. This is a valuable service. Let's not charge people. Let's not penalize them for it. And incidentally, by the way, during Hurricane Dorian just a month or 2 ago, actually just a month ago, there was a waiver granted for use of specific digital modes that are normally not allowed in certain amateur radio bands, something called PACTOR. And the FCC extended the waiver for the entire duration of the hurricane recovery operations. So again, the FCC is very much in tune with recognizing the service that amateur radio provides.
Bill, what about the technical side of the requirements for licensing? Yes.
I do. I have a slide about that. So aftermath, we don't need to see this, blah, 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 blah. Okay. So just two things here. So practice makes perfect, and I think that's true in a lot of things in life, if not everything in life. There are contests almost every weekend. And you say, what's a contest? Well, we go to some station, maybe our own, if we have one at home, or maybe a collaborative station, or maybe a radio club at a university, and we talk to people around the world. And you get a score. How many people did I talk to? How many countries did I talk to during the time period? I multiply some things together. I add them up for each band that I've communicated on, and I get a score. And I get bragging rights because I won for Central Florida, or I won for Nantucket County, Massachusetts, or whatever it might be. But there are these contests that are really, they're opportunities to improve your skill. Essentially, they're practice. They're practice for the delivery and crisp handling of information over a two-way radio link. I prefer the ones in Morse code. I'm fluent in Morse code. Can you say that? I can do Morse code sending and receiving at 60 words a minute. I've been able to do that since I was 14. So I love that. The thing about that is that you don't have to spell things out because they're already spelled out. I mean, you're spelling when you send it. If I send Bill, it's dotted it, and I don't have to figure out what I just sent and say, was that a B or an L? Because it's already spelled out for you. There are also these things called simulated emergencies that these organizations I talked about conduct on a regular basis. And then there's the big mama of all rehearsals, which is something called Field Day. And Field Day is an activity that happens every June all over the United States and Canada. And people literally start off with a mountaintop, an open field. In Orlando, we do it just east of the executive airport near the 911 center, coincidentally, but it just happens to be a big open field that's owned by the city. And we drag our towers and coax cables and radios and tents and what have you, and coolers of, not beer, but coolers of soft drinks and things like that. And we set them up in as quickly as we can, and we start transmitting to other people who are doing the same thing that we're doing. Last year, 2018, 1,253 people entered this particular competition in the so-called temporary station category, which means they started with an open field and they put up towers just like the one you see in the picture here. 35,000 people participated in this competition, and it happens every June. And it's a rehearsal. It's called Field Day. So what are the takeaways? First, the key to successful emergency service response is preparation. Duh, we know that. The key to many things in life is preparation. But to be effective, disaster relief communication must be well coordinated and well executed by competent, well-trained personnel. Now remember, we're not dealing with people who are working for the government, who are working for private sector. We're dealing with people who are volunteers. So the onus is on these volunteers to get themselves trained by participating in one of these organizations. And as we talked about at the beginning, whether it's cellular, fixed wireless, wired internet, point-to-point, no network is infallible. Something is eventually going to fail. Something is eventually going to break, in particular when you need it the most, and that's during a natural disaster. So there have got to be backup plans in place as to how you're going to deal with that emergency if your primary service is not available. Infrastructure, equipment, processes and procedures, and those are all taken care of, available manpower, specialized training, and so on and so on and so on. So just a couple of final thoughts. You probably are surprised at this because you think that ham radio operators are that old guy in the basement next door who winds enameled wire around toilet paper rolls and then builds something that makes sparks. No, that's 1940s thinking. There are 822,000 licensed amateur radio operators in the United States. So I'm actually very happy to see that we have some in the group today because, as I said, I was really disappointed when I talked to a group of geeks in Florida, and nobody was a ham, not a single one. By the way, my wife is a licensed amateur radio operator, and so is my daughter. So it's also contagious, so be careful. Entry-level licensing is easy. It takes about a week. I mean, you people in the room here, the technical part of it, I'm sure, is a slam dunk. There's a bunch of regulations you'll need to learn. What can you do? What can't you do? Under what circumstances can you do that? And nomenclature and naming and what are certain modes called and so on and so on. $50 worth of study books. That's all you need. You can even go online and you can find study guides that are available for free. And local clubs hold classes and administer the exam. Last weekend I was in Melbourne, Florida at the Melbourne Ham Fest. That's a fairly common term for a group of ham radio operators getting together to swap things at a swap meet and listen to presentations about who's doing what to whom and newest technology and operating techniques and things like that. And they offered classes. They also offered exams. So a number of people were sitting in the room, young people, fortunately, taking the exams, and they'll be off and running with their licenses fairly soon. So that's all I have for you today, and I'm sorry that I went 11 minutes over, but I actually got handed the baton with 12 minutes, so I'm actually 1 minute early. So, thank you.